Welcome to this session on the Microsoft Graph PowerShell SDK. My name is Daryl Miller, and I'm an API architect on the Microsoft Graph Developer Experience team. I'm joined today by Peter Amboise, who's going to be doing some demos for us. Now, we can't talk about the PowerShell SDK for Microsoft Graph without first speaking about Microsoft Graph itself. Microsoft Graph is a large HTTP API. It's the data API for the Microsoft 365 ecosystem. But more specifically, what is Microsoft Graph? And what does it compose of? There are many teams that build the applications and services that make up the M365 ecosystem. In the past, each of these teams exposed an API. Microsoft Graph consolidates these efforts under a single consistent API. This means one set of documentation, one API token, one set of consistent tooling and SDKs in order to bring a consistent developer experience that makes you more productive. The Graph Developer Experience team produces SDKs in different languages to accommodate different audiences and bring a complete set of data and functionality to as wide an audience as possible. PowerShell is now a part of that family of SDKs. Before, PowerShell users had one of two choices. They either found a module for each of the functional areas that they needed to interact with, learn each one's conventions, log in for each module, and glue them together. Or they could craft HTTP requests manually using invoke REST request. Now we have a cross-platform solution. It works in Windows PowerShell 5.1 and on PowerShell Core across all 8 operating systems. And it covers the entire Graph service area, V1 and beta, and it will be regularly updated. The PowerShell SDK is a convenient way for PowerShell users to call the APIs of the Microsoft Graph. It can be used directly from the PowerShell command prompt. It can be used in scripts, and it can be used by other modules to build richer scenario-based commands. It's an important distinction to make that this module is an automated projection of the Microsoft Graph API. We've tried to make it feel like as natural as possible to PowerShell users, but there's still a very high correlation between how things are done in the Microsoft Graph API and how they are done in our PowerShell commands. And this is a common pattern for all of our SDKs. We do expect some teams at Microsoft to build richer scenario-specific commandlets on top of the commands that call the APIs. But this value this library brings is with a common type model, a common authentication system, and complete API coverage that is regularly updated. So when teams bring add-on modules, there will still only be one login required, and teams can focus their attention on the specific scenarios where they can bring a lot of value to common use cases, and they don't have to worry about covering every edge case. I want to talk and show some examples specifically of how this mapping occurs between the graph calls and the PowerShell calls. And I've taken these samples straight out of our documentation where we show you how to make the same calls to graph, but in different languages. And PowerShell is now a first-class citizen. So you'll see here in this HTTP GET call to the graph, we call users from pass a user ID. The equivalent in PowerShell is get-mguser. The MG stands for Microsoft Graph, and that is a prefix that was requested by the community to ensure that our commandlets don't interfere and overlap with existing ones that they may be using. Now, when you call get-mguser, it's going to retrieve the entire user object, but we're actually making a call across the network here. So the way that you usually handle this in the Microsoft Graph API is you're able to project just the properties that you are interested in with the $select parameter. And the equivalent parameter in the PowerShell world, you can use -select, but we've found that a more natural experience for PowerShell developers is to use .property to project. So here in this case, we're saying get mguser, providing a user ID, and saying just bring me back the display name and job title. Now, you can still use select object to the standard way of projecting within PowerShell, but you'd be bringing all the properties back and then just using some of them, which is less efficient. The same mechanism can be used with filter, where filter in the HTTP URL is an expression or a query parameter that says only bring back a certain set of rows. And there is an equivalent parameter in our PowerShell commands for providing that condition to reduce the number of rows that come back. If there's certain filter conditions that aren't supported by the API, you can still use the where object command. You'll also notice that in this particular command, we are getting the email messages that belong to a particular user. And if you look in the URL, there's a user segment and a messages segment. And we bring these keywords together in order to compose the command for PowerShell. So we have get mg user message. And that's a convention that you will see across all of the PowerShell commandlets that we generate. If you wanted to access just a specific message, then you can see in the URL there's a user ID and a message ID, and they correspond directly to parameters to the get mg user message command. When it comes to creating new objects, in the OData style of calling an HTTP API, you use the post HTTP method to create it. That's not the convention within PowerShell, so there's a mapping that happens. So we convert post over into new. On the graph, there are all kinds of actions and functions, and sometimes these map to PowerShell verbs, in which case we will do the mapping. Otherwise, we'll resort to the standard invoke dash method of identifying those kind of action-based commands. When you're creating objects, you often need to pass an object on the REST API. It's via a JSON object. We attempt to flatten those objects into a set of parameters, so you have to do less construction of objects in PowerShell. Sometimes it's not always possible, and you can use the standard PowerShell syntax in order to create maps and arrays to be able to pass those kind of objects to more complex PowerShell commands. So that gives you kind of an overview of how you can do some of the basic operations with Microsoft Graph. But how do you get started? Well, it's as easy as this. Install-module Microsoft Graph. Microsoft Graph is actually a meta module, and it will pull in a whole set of other modules that provide you access to all the different capabilities within Microsoft Graph. So, enough slides. Let's get straight over to a demo, and Peter's going to show you how to actually use the library in an interactive experience.
Thanks, Daryl. I'm Peter Ombwa, a software engineer on the Microsoft Graph Developer Experience team. In this demo, I'll walk you through how to use Microsoft Graph PowerShell SDK in interactive scenarios. So let's get started. In this demo, I'll show you how to use Microsoft Graph PowerShell SDK to make interactive calls. For interactive experiences, the SDK uses device code flow to get an access token on behalf of the signed-in user. This is the default behavior that you get when you call connect graph with -scopes parameter. This demo is divided in two parts. In part 1, we will create, manage, and later on delete a team. And in part 2, we will create an app registration with a certificate in an interactive mode. So let's get started with part 1. Before we create or manage an app, we first of all need to identify which permissions we need to consent to. In this case, I have all my permissions listed here. To consent to these permissions using our SDK, I'll call connect graph, passing those permissions to our scopes parameter. I'll be prompted with a device code and a device login URL that I'll click. I'll paste my code here, sign in, then consent to the permissions that this app requires. Once I've consented, I'll go back to my app and I'll be presented with this welcome to Microsoft Graph message informing me that I've successfully authenticated to this app. Next, I'll create a team for our 2020 interns. To do this, I'll use new mg team command, setting our display name and description name to our team's name. This is 2020 interns. And we'll also add our teams template using an additional properties. This creates a team for me. This team is named 2020 interns. Next, I'll use getMgGroup command to filter groups by display name and resource provisioning options to find the team that we just created above. getMg command has a dash filter parameter that you can use to pass your OData filters. And at the same time, you can also perform a client-side filter using a where object. In this case, I'm checking groups that have a resource provisioning options that contains a term team. This will give me back our interns team that we created. And indeed, we can see all the properties here. Next, I'll want to add an owner to this team. To do that, I'll first of all need to get a user ID. For me, I only have Adele's UPN, and Adele is supposed to be the owner of this team. To get their user ID, I'll call getMgUser, setting Adele's UPN as our user ID. This will give us back a user object, and in this user object, we will be able to get that user ID by calling the .id parameter in it. So let's see. So if I type team owner .id, I should be able to see Adele's ID here. Using Adele's ID, I'll call new mg team member to add Adele as an owner of this application. New mg team member accepts a roles parameter, and in this roles, I'll specify Adele as an owner. At the same time, I'll also use additional properties to bind this user ID to this request. This adds Adele as an owner to this team. Now that we've added an owner for this team, we want to find users in our organization who have a UPN that starts with a T-. This T- prefix will be the hint that we'll use to find the interns in our org. To do this, I'll call getMgUser with a dash filter parameter, and I'll get users who have a user principal name that starts with a T-. This will give me back a list of users. I can get those users' display name and user principals by calling that variable with a pipe and then selecting their display name and user principal name. And here I can see those details. Now that we have a list of users to add to the team, we will go ahead and iterate through those users, adding each user as a team member with the role of member. To do this, I'll use new mg team member command that we used up above to add Adele as an owner, but in this case, I'll switch the role to a member. This goes over all our users and adds them to this team as members. Now that we've added them to the team, we want to get that team's primary channel so we can send them a welcome message. To do this, I'll call getMgTeam primary channel with a team ID of the team that we created above. This should give me back a primary channel object. Now that we have our primary channel, I'll call new mg team channel message to send a welcome message to that team's channel. To do this, I'll set our team ID to our intern's team ID, the channel ID to our primary channel, and the body content will be set to welcome to teams. So let's send them a message. And success, a message has been sent to that team's channel. Now, we'll hop over to Teams and ensure that everything was created and the message was sent successfully. Here, I see the team that we just created in PowerShell 2020 interns. If I go to the general channel, I'm able to see the message that I sent to this channel. I'm curious to see how the membership structure is in this team. Oh, great. Here I see Adele and myself as a team owner, and all the other interns that we added as team members. This is exactly what we wanted. Assuming that our interns have left the company, we can remove this team using remove mg group command, passing our team ID to the group ID parameter. This will perform a soft deletion on this team. And the team was removed successfully. In part 2 of this demo, I'll show you how we can create an app registration with a certificate in an interactive mode. So let's get to it. In order for us to be able to create an app, we first of all need to perform an incremental scope consent to application.readwrite.all permission. Luckily for us, Connect Graph supports incremental scope consents. So I'll just call Connect Graph, passing our extra scope to our dash scopes parameter. I'll be presented with a device code. I'll click on this link and I'll paste that code here. And I've signed in successfully. If I go back, I'll get this welcome message informing me that my authentication request was successful. Now that I've authenticated successfully and I'm able to create an app, I'll get a certificate by thumbprint from my current user store. To do this, I'll use PowerShell's getChildItem command. This will give me back a certificate object. And in this certificate object, I have all the properties that I need to consent. Next, I'll take note of Graph Resource ID. This is needed because this app will use Graph as a resource. Also, I'll need the following permissions in order for me to access Graph as a resource, and that is user.read.all, group.read.all, mailbox-settings.read, and mail.send. Once I have those permissions in place, I'll then go ahead and call new mg application. This is the command that we will use to create our app registration. To do this, I'll set its display name to scripted graph ps, set its sign-in audience to Azure AD org, then set its redirect URL to localhost. Also, I'll set its required resource access, resource app ID, to the graph resource ID that we took note of up above. And then for its resource access, we will set those graph permissions that we will need later on in order for us to access graph through this app. For our key credentials, I'll set our certificate's raw data as the key, and then set this key as a type of asymmetric X509 certificate. So if I execute this command, I should be able to create a new app that we will use later on in our scripted demo. So if I inspect this app registration object, I'll see all the properties have been populated here, which means that this app was created successfully. Also, if you want, you can call new mg service principal, passing in that app ID that we have to convert this app into a service principal. In our scripted experience demo, I'll show you how we will use this app registration to get an access token for Graph without a user.
Thanks, Peter. That's great. So now you've seen how to do a set of common operations that you might want to do to be able to get access to all of the richness of the data set of Microsoft Graph. So from here, we're going to go a little bit deeper. We're going to go behind the scenes and spend a little time digging deeper on how that we actually build this SDK. So I mentioned earlier you can do install module Microsoft Graph, and that is our meta module. And it pulls in a set of other modules. All of the modules depend on Microsoft.graph.authentication, which is the library that goes and gets you a token. And there's some real other handy features that are in Microsoft Graph.authentication. There is a invoke graph request. Think of it as like invoke REST request, but with an auth token automatically provided for you. So it's kind of always the escape hatch. If there isn't a module to be command to be able to do what you want to do, you can always go back to using invoke graph request. And then when you're building applications or scripts that use modules, you can pull in, if you want just the modules, if you're just working with mail messages, you can pull in Microsoft Graph.mail, you can pull in Microsoft Graph.calendar in order to get access to the capabilities in those modules. And as new features become available on the graph, we will update those specific modules. And so when you do an update, you won't necessarily have to download all of it. You'll just get the updated modules. The Microsoft Graph authentication is built on top of another library that we use throughout the SDKs, which is the msal.net library that provides modern auth features. And it's built by the Microsoft Identity team. And they incorporate new features regularly. This is what provides us with the device code flow and the client credentials flow, and all of the nice features that enable MFA, the multi-factor authentication and conditional access, and it gives us all the token caching. So we can be sure that you get a solid, consistent experience there. There's no point us reinventing that wheel. And then we also take advantage of the Microsoft.graph.core library, which is the core part of our C# or .NET SDK. And it provides a pipeline of middleware for doing throttling and retry handling. So you don't have to do that in your scripts. We'll take care of it for you. We can handle compressing and decompressing payloads and doing sophisticated connection management mechanisms. And as we continue to innovate in these areas, these benefits will flow right up into all of the PowerShell modules. So let's dig a little bit deeper on how do we actually make these modules. And you might ask, well, why should you care? And obviously you don't have to. You can just take these modules and you can go ahead and use it. But this is an open source project on GitHub, and maybe you want to contribute. If you find an issue, maybe if you know how it's put together, you can help us fix it. If you have an API described in OpenAPI, maybe you're interested in creating PowerShell libraries for your own API. And this talk got a 400 level label, and I love going into geeky levels of details. The Microsoft Graph metadata is updated on a weekly basis. Teams are constantly adding new features into the API, and we take that update as a trigger in order to update our metadata files, which are large XML files that use CSDL that describe OData APIs. And we also take this data, including the documentation, and we bring it into an open API converter. And we use this module mapping file to kind of split the overall graph metadata into modules, which we can then feed into the auto-rest generator. Now, the auto-rest tooling is a tool that has been built by the Azure SDK team, and they are using this generator in order to create their PowerShell SDKs for Azure. And so by using the same set of tooling, we're able to get a consistent experience because more and more IT admins and developers are using the capabilities both in the Graph side and the Azure side. So the more consistency, the better. Now, the auto-rest PowerShell generator is a very clever generator. It generates based on a set of conventions, but also allows us to inject a set of customization directives. So if we want to tweak a name that doesn't quite feel right, or if there's a particular commandlet that shouldn't be included in the PowerShell, we can change that with the customization directives. We can also, at this point, bring in custom scenario commandlets. Teams can specifically add their own commandlets that have these richer scenarios, and they will be incorporated into the Microsoft Graph PowerShell modules, which then get deployed onto the PowerShell gallery. And it is just a consistent, holistic experience for the consumer of the Microsoft Graph PowerShell library. And so let's talk about what else we can do with this library. Interactive experience is great and allows you to do all kinds of ad hoc things, But PowerShell is also incredibly useful for non-interactive scripting type experiences. There are all kinds of scenarios for provisioning teams and groups and users and sites, migrating of data, migrating teams data, migrating users, synchronizing of data, synchronizing of files between on-prem and the cloud, being able to synchronize SharePoint lists, membership of groups. There's just a wide range of capabilities. Reporting is another capability that is very common on Graph. So usage and activity and ownership, licensing. If you're a PowerShell user, you're probably very familiar with all of these different scenarios. And the Microsoft Graph PowerShell SDK gives you these capabilities across all of the data in the Microsoft Graph. And so for our next demo, Peter's going to show you how to build a scripted experience using the Microsoft Graph PowerShell SDK. So over to you, Peter.
In this demo, I'll walk you through how to use Microsoft Graph PowerShell SDK to make app-only calls using a certificate. I'll be using the app registration that we made in our previous interactive experience demo. Here, I have a script called usersandgroups.ps1, and in this script, I'll be getting members of a group, looping over them to find which members work on a weekend, and sending those affected users an email informing them to update their mailbox settings. So let's have a look and see how all this is written. Here, I have a tenant ID, and this tenant ID will be used to construct an admin consent URL. This is the URL that our admin will use to consent to this app before we use it, since this is a confidential client app. Next, I'll get my client ID from the app registration that we made in our previous demo. Using that client ID, I'll call connect graph, passing it a client ID, a tenant ID, and a certificate thumbprint. One thing to remember here is that this certificate needs to be in your current user store. This call will authenticate us as a confidential client for app-only calls. Once we've authenticated successfully, I'll call getMGroup to find a group with a display name of weekday employees. This should give me back a single group. Next, I'll call getMGroup to get members of this group that we've filtered up here. This will be a collection of members rather. We will then loop through each member, and for each member, I'll call getMGuser, selecting their display name property, mail property, and mailbox settings property. This will give me a single user object with the following properties in it. Next, I'll inspect the user's mailbox settings to check if they work on a weekend. And if that user works on a weekend, we'll add them to our toRecipients array, adding them as an email address where the name is equals to the display name of the user and the address will be the user's mail. Once we are done looping through all our group members, we will then go ahead and compose a message to those affected users and add them to our toRecipients with a subject of this and a body content of text and a body content of that. Since this is an app-only call, we need to get a user who will send this mail to those affected users. In this case, my user of choice is Adele V. I'll then call getMGuser to get the user so I can get their ID. Once I've gotten that user ID, I'll go ahead and call sendMGuserMail, passing a user ID of admin.id and a body parameter of the message that we composed up above. Once this call is successful, those affected users should receive an email informing them to update their mailbox settings. Once we are done with everything, we will go ahead and call disconnect graph to log out of this application. So let's run this script to see how everything works. To run the script, I'll just need to find where it is. That's under scripts and run that script. Here, I'll be prompted with that admin consent URL that we saw. So I'll just click on it. This will ask me to consent to this app as an admin, and these are the permissions that this app uses. These permissions were presented to this app when we created it in our interactive experience demo. Once we've consented to the app, if we go back, I'll just press any key to continue. and that will tell me welcome to Microsoft Graph, which means I've successfully authenticated to this app. And there we go. The app is listing for me users who have an invalid Workday setting in their mailbox and an email has been sent to them. Oh, actually see, I'm one of them. So with that, if I was to go to my mailbox and check my mail, let me just log in. Hey, I should be able to see an email from Adele. And the email is telling me, please update your mailbox settings. This is one example of how you can use our Microsoft Graph PowerShell SDK to make app-only calls silently. Thank you.
Thanks very much, Peter. That was awesome. So now we've seen how to write scripts that can be run in non-interactive mode. It's worth calling out that one of the steps Peter included for doing consent, that consent process only has to be done once. So it doesn't need to be in the script, but it is an essential process to do once. We have mentioned that we are doing regular updates based on metadata, but we also have a pretty good backlog of features that we would like to add to make the experience even better. We want to be the platform to build upon, as well as providing all of the capabilities directly from the Graph API. We want to be able to give you a common auth experience for any capability in the M365 platform. And we've talked about being able to put custom commands in the box and package them up with the PowerShell SDK. But there's another option that teams have. They could create modules that just simply take a dependency on our library. And I mentioned this is a way that they can provide those richer scenarios while still getting the benefits of this single token experience, common experience, and shared infrastructure. And we're having extensive conversations with the Azure AD team and the Intune team and other teams, the community projects like the desired state configuration team that provide ARM-like capabilities for the Microsoft 365 ecosystem. And System Center Object Management is another team that we're working with. And of course, the PnP PowerShell community project, who works specifically on creating really simple, easy to use PowerShell commandlets. They could leverage our core library to bring all kinds of additional benefits and consistency to their library. So we will continue working with these teams to provide this holistic experience. More specifically, looking at particular capabilities that we want to build. Very soon, we will have sovereign cloud support. Initially, we will just support the public cloud, but all of the other clouds will be coming very soon. And along with that will come support for business to consumer type of domains. We're working very closely with the Azure team, and the Azure Identity Credential mechanism is something that will bring us the ability to sign in using managed service identities and use Key Vault in order to be able to store secrets. And we want to be able to do single sign-on with the Azure PowerShell library. So you won't even have to sign on once for Azure and once for Graph. We can just do a token exchange and be able to call both sets of APIs with a single login experience. More specifically around feature work, I mentioned the PowerShell filter. Currently, it's no data string that you have to construct. It would be much nicer experience if people could use just regular PowerShell expressions, and we can do that conversion over to an OData expression. Long-running operations we support, but we don't give you that ability yet to be able to then monitor that operation as it progresses and to detect when it is actually complete. So there's additional work that we want to do there. We'd also love to be able to bring the batching support that exists in Graph and bring that to PowerShell. So you could collect together a set of commands that you want to run and call Graph in a single command with that set of commands. On the developer experience side, I showed you some of the snippets that are in some of our conceptual documentation. But over in our reference documentation, we auto-generate snippets for our languages like C# and JavaScript and Java. And we want to do the same for PowerShell so that you can go and look up some content on the graph and then immediately be able to see, this is how I make this call in PowerShell. Which brings us to our last bullet point, which is definitely not least. The CLI is a capability that we are going to build using a very similar set of techniques. We use the Autorest PowerShell generator for generating our PowerShell library, but the Autorest team have also built a CLI generator. So we can take those same inputs, the Open API documents, feed them into the CLI generator, and it sits on top of, this time, a Python core. And this will bring you the ability to access all of the data and the functionality of Graph using a CLI experience instead of PowerShell, depending on if your scenario says CLI makes more sense for your scenario. And so my call to action to you is go try it out. It's really easy. Open a PowerShell command prompt, install module Microsoft Graph, and away you go. You can request features and report issues on our GitHub repo, and you'll find additional samples there. We hope you find this a really valuable tool, and thank you for listening.